In this project, the requirement is very simple and very common, especially for small business or beginners. A small business wants to deploy a simple web application on AWS. Let's break down what it really means. First, the application. It is a basic web application. It could be a company homepage, or landing page, or a simple internal demo. It does not require high traffic. It does not require high availability or complex scaling. Second, the business side. This is a small business, not an enterprise. Cost is an important factor. Simplicity is very important than advanced feature. Thus, the article is specification. The application must be accessible from the internet. Users should be able to open it using a browser. Administrators should be able to manage the server using a So from an AWS SM or architecture perspective, this requires tell us we need a minimal, low cost, easy to understand architecture and demonstrate the core AWS networking concepts. That is why this architecture focus on one VPC, one public subnet, one EC2 instances, basic security configuration. This is a perfect learning architecture and also a very common SM scanner. Architectural overview. Now let's look at the big picture of the architecture. The solution deploy a simple, cost-effective web application that is published accessible from the internet. Key design decision. First, single availability zone. We use only one availability zone. This will reduce cost and complexity. High available is not required for this project. Next, core AWS networking components. This architecture intentionally focuses on fundamental AWS services, including VPC, Subnets, Internet Gateway, route tables, security groups, EC2. There are core services that appear very often in AWS SM, rework-based deployments, beginners to intermediate projects, and that clear learning objects. The goal is not performances or scales. The goal is to clearly understand how the internet traffic reach an EC2 instances in AWS. So this architecture is designed to visually and logically demonstrate how networking components work together. Networking layer. The networking layer is a foundation of the architecture. A VPC is created first. Think of a VPC as your private network inside AWS, similar to a data center network but in the cloud. Why do we need a VPC? To isolate our resources, to control IP addressing, to control traffic flow and security. Without a VPC, nothing can communicate properly. Next, public subnet. Inside the VPC, we create one public subnet. A subnet is a small network inside a VPC placed in one availability zone. Why is this subnet called public? Because it has a route to the internet gateway. Services inside it can communicate without the internet. This is a critical SM concept. A subnet is public only if it has a route to an internet gateway. Net, internet gateway. An internet gateway is attached to the VPC. Its role is very simple. It allows traffic between the VPC and the internet. important points. One internet gateway per VPC. Without an internet gateway, internet traffic cannot enter or leave the VPC. Think of it as the door between your AWS network and the public internet. Route table. A route table is associated with the public subnet. It contains a key rule destination for 0/0 and target internet gateway. This rule means any traffic going outside the VPC should be sent to the internet gateway. This rule is what makes the subnet publish. Without this rule, even with a public IP, even with an internet gateway, and the instance would not be readable. Computer layer. Now let's move to the computer layer where the application is detected to run. Amazon EC2 instances. We launched one EC2 instances inside the public subnet. Why EC2? Simple, flexible, very common in SM and real work user. This EC2 instances represents the web server, the application host. Web server. On the EC2 instances, we install lightweight web server such as Apache or Engine. Its job is simple: receive HTTP request, return web content. This is enough to demonstrate internet connectivity, application accessibility. Net public IP address. The EC2 instance has a public IP address, optionally or an elected IP. Why is this important? Because the internet cannot directly access private IPs. The public IP is required for inbound internet traffic. This public IP works together with the internet gateway, the route table, the security group. Net cost efficiencies. Only one is EC2 instances. No redundancies, no scaling, very low cost. This lines up perfectly with learning goal, small business needs, SM style simplicity. Security layer. Security is controlled using a security group. A security group is a stateful firewall attached directly to the EC2 instances. Inbound rules. Inbound rule define what traffic is allowed into the EC2 instances. We configure two rules. First, SSA port 22 allow only from a specific trust IP used for administration, and this prevents unauthorized access. Next, HTTP port 80 allow from 40/0. This allows anyone on the internet to access the website. This is safe because HTTP is meant to the public. No sensitive data is exposed. Outbound rules. Outbound rules allow on outbound traffic, while the instance may need to download updates. The instances may need external communication. This is common and acceptable for basic stuff. This is a privilege principle. Only required ports are open. No unnecessary exposure. Reduce attack surface. This allows AWS security best practice. Traffic flow is explanation. Now let's walk through the end-to-end traffic flow step by step. First, a user opens a browser. Net, the request goes to the EC2 public IP. Net, traffic enter AWS via the internet gateway. Next, the route table directs traffic to the public subnet. Next, the security group allows HTTP traffic, and the EC2 web server response. This flow clearly shows how AWS networking components work together. Why each component is required. This is very important. For example, cost and cost consideration. To keep things simple and affordable, we intentionally exclude advanced services. But no load balancer. Why? Only one EC2 instances. No need to distribute traffic. Net. No auto scaling group. Why? Traffic is low. Scaling is not required. Net. No NAT gateway. Why? No private subnet, and internet access is direct. Net. No multi-AZ. Why? Cost saving decision. Acceptable risk for small projects. This keeps cost low. Architecture easy to understand. Demo app. Now, we are going to build a VPC with public subnet, an internet gateway, and a route table that allows internet access. First, we create a VPC. The CI/CD block defines the private IP RAN of this network. DNS support and DNS host name are enabled so that EC2 instances can resolve DNS names and receive public DNS host name if needed. net. We create a public subnet inside the VPC. This subnet is placed in a specific availability zones. The key setting here is the map public IP on launch, which automatically assign a public IP to EC2 instances launched in this subnet. Then we create an internet gateway on the VPC. The internet gateway is what allows traffic between the VPC and the public internet. Without an internet gateway, resources inside the VPC cannot reach the internet. Now we define a row table. The row table for euro per euro means on outbound traffic. By pointing this row to the internet gateway, we allow traffic from the subnet to reach the internet. Finally, we also adjust the row table with the public subnet. This step is critical. Without this association, the subnet would not actually use the internet route. Subnet is only public if it is associated with a row table that routes the traffic to the internet gateway. Summary: we create a VPCs, a public subnet at that an internet gateway, and define a routes to the internet, and associated that row tables with the internet. That is the minimum setup required to run internet-facing resources on AWS. We are going to define a security group. A security group acts as a virtual firewall that's controlling inbound and outbound traffic at the EC2 instances level. First, we create a security group inside a specific VPC. Security groups are always associated with a VPC and are used to protect resources like EC2 instances. This inbound rule allows SSA access on port 22 using TCP. The CIDR block for euro per euro means SSA is allowed from anywhere on the internet. For production environments, SSA should usually be restricted to a specific EP RAN, not open to the world. This rule allows HTTP traffic on port 80 from any IP address. This is required so users from the internet can access our web application. The outbound rule allows on traffic to any destination. This is the default and most common configuration, allowing the instances to access the internet download updates or call external services. Security groups are stateful, meaning if inbound traffic is allowed, the return traffic is automatically permitted. They operate at the instances level, unlike a network ACLS, which works at the subnet level. To summary, this security group allows SSA access for administration, HTTP access for public users, and unrestricted outbound traffic. This follows the principle of control inbound access while keeping outbound traffic simple. We are going to launch an EC2 instance using Terraform. We'll dynamically select the elastic Amazon Linux AMI as a security setting, bootstrap the instances with the user data, and optionally assign an elastic IP. Instead of hardcoding an AMI ID, we use a data source to dynamically fix the most recent Amazon Linux 2023 AMI. This makes the configuration more maintainable and region independencies. The filter. And so we only select 64-bit Amazon Linux AMI owned by AWS. Here we create an EC2 instance using the AMI. We just select the instances type defined as a variable. The instance is launched inside a specific subnet and protected by a security group. We also explicitly associate public IP address so the instances can be accessed from the internet. Public IP plus internet gateway plus row table is what makes these instances internet accessible. The key pair is used for SSA access. This method references an existing key pair in AWS, allowing secure login to the instances. User data is a bootstrap script that runs only once when the instance is first launched. Here we install Apache, start a web server, enable it on boot, and create a simple HTML page. This block conditionally creates an elastic IP. If enabled, the instance receives a static public IP address that doesn't change after reboot or stop start. To summarize this configuration, launch an EC2 instance using the elastic Amazon Linux AMI, secure it with a security group, and a key pair bootstrap it with user data, and optionally assign an elastic IP for stable internet access. In this lesson, we are using Terraform module to organize our infrastructure. Modules help us keep the code clean, reusable, and easier to maintain as the project grows. First, we call the VPC module. This module is responsible for creating the networking layer, including the VPCs and the public subnet. Next, we create a security group using a separate module. Notice how we pass the VPC ID from the VPC module into this module. This shows how modules can depend on each other in a clean and explicit way. Security group must belong to a VPC, so this dependencies is required. Finally, we launched the EC2 instances using the EC2 module. The instances is placed in the published subnet and protected by the security group we just created. How modules work together? The VPC module provides networking resources. The security group module depends on the VPC. The EC2 module depends on both networking and security. Terraform automatically builds the dependency graph based on these preferences. Summary: to splitting the infrastructure into modules, we separate concerns: networking, security, and compute. This makes the configuration easier to understand, review, and scale. It is the folder structure. To look at it, architecture. First, provide public internet access to a web application. Net demonstrates the core AWS networking concept. Net uses a minimal single agent design. Net is cost-effective and essentially. And finally, follow AWS best practice for basic setup. Thank you.